Dear colleagues, let me introduce to you our research, the wind generator power effective forecast method based on modified one-dimensional convolutional neural network and metaheuristics. Currently, one of the most important problems in the field of processing technical information is its infinitely higher accuracy and speed. Of particular relevance is the information processing from technical objects with higher dynamics. Therefore, the development of methods for predicting the characteristics of technical objects with higher dynamics is an urgent task. An example of such an object is a wind generator. Traditional forecasting model. Autoregressive model, autoregressive moving average model, the forecast neural network are Elman neural network or simple recurrent network, bidirectional recurrent neural network, long short-term memory, bidirectional long short-term memory, gateway recurrent unit, bidirectional gateway recurrent unit. Purpose of the research is to increase the efficiency of the wind generator power forecasting due to a modified one-dimensional convolutional neural network trained on the metaheuristic method basis. Objectives of the research: to create a forecast model based on a modified one-dimensional convolutional neural network. To select a criterion for evaluating the effectiveness of the proposed model, to develop a method for parametric identification of the model based on local search, to develop a method for parametric identification of the model based on metaheuristic search, to conduct a numeral study. It is proposed to replace a recurrent layer in the forecast neural network with a one-dimensional convolution layer, a one-dimensional pooling subsampling layer, and a dense fully connected layer, which allows extracting the most significant features with further forecast. Also, formulas are proposed for a one-dimensional convolutional neural network and for calculating the number and sizes of convolution, pooling, and dense layers. The forecast model based on a modified one-dimensional convolutional neural network is presented in the following form. The convolutional layer computation, the pooling subsampling layer computation, and the dense fully connected layer in combination with the flattering of the pooling layer computation. The output layer computation. To assess of the suggested model effectiveness, it is necessary to select a criterion. To assess the suggested model parametric identification, a model adequacy criterion was chosen. It means the choice of such parameters value, which deliver a minimum of the root mean square error, the difference between the estimated output and the truth output. Respectively to this criterion, methods for parametric identification of the model are suggested. The method development for suggested model parametric identification based on an adaptive cat swarm optimization. Block 1. Initialization. Setting the number of the current iteration n to 1. Setting the maximum number of iteration n. Setting the size of the swarm k. Setting the dimension of the cat's position m corresponds to the number of proposed model parameters. Setting the number of a cat's position copies L, setting the probability of the search mode psearch, position initialization xk corresponds to the vector of a proposed model's parameters. Also speed initialization vk, setting an initial swarm of cats, the current population cat with the best position determination corresponds to the vector of the proposed model parameters with the best goal function. Block 2. Search mode. The cat is in rest but looks around to move a new position. Copying of each cat's position. Calculating the probability for a copy of each cat's position and changing the position of each cat. Block 3, tracking mode, cat looking for a target. Modifying the speed of each cat using simulated annealing, and modification of the position of each cat according to the speed. Block 4, setting a new population. Block 5, determine the current cat population with the best position. Block 6, determine the global best position. Block 7, stop condition. You can see structural representation of a prediction model based on a modified one-dimensional convolutional neural network. Numeral research. The neural network forecast of the wind generator power was carried out according to such characteristics as wind speed, humidity, and air temperature. For an effective experiment, training and test implementations were obtained from a wind generator, Winder T12. Parametric identification of the modified model was carried out on Q equals 10,000 trainings implementation based on the proposed meta-heuristic search. The following parameters was chosen: the maximum number of the iterations, the size of the swarm, the number of copies of the cat's position, the probability of the search mode, and table 1 shows the prediction accuracy obtained for 1000 test implementation based on the proposed modified model and traditional models of artificial neural networks. Conclusions. To solve the problem of insufficient quality analysis of the wind generator's power, the corresponding neural network forecasting methods were investigated. To improve the efficiency of training neural networks, meta-heuristic methods have been investigated. The model of the modified one-dimensional convolutional neural network, by automatically calculating the convolution layers, number and sizes, pooling, subsampling, and dense fully connected layers, allows to extract the most significant features, which increases the forecast accuracy. The method of suggested neural network model parametric identification, due to the lack of recurrent links, allowed to use of a batch training mode, which increases the training speed. The method of proposed neural network model parametric identification, based on the adaptive optimization of a swarm of cats through the use of simulated annealing, makes possible to make the search global at the first iterations and to make the search local at the last iterations, which increases the forecast accuracy. The method for predicting of the wind generator power, based on a modified one-dimensional convolutional neural network, can be used in various intelligence systems for analyzing the characteristics of higher dynamics technical objects. Thanks for your attention. My speech is over.